A new artificial intelligence algorithm has discovered over 300 previously unknown exoplanets in data gathered by a now-defunct exoplanet-hunting telescope. The Kepler Space Telescope, NASA's first dedicated exoplanet hunter, has observed hundreds of thousands of stars in the search for potentially habitable worlds outside our solar system. The catalog of potential planets it had compiled continues generating new discoveries even after the telescope's demise. Human experts analyze the data for signs of exoplanets, but a new algorithm called ExoMiner can now mimic that procedure and scour the catalog faster and more efficiently. The telescope, which stopped working in November 2018, looked for temporary decreases in the brightness of stars that may be caused by a planet crossing in front of the star's disk, as seen from Kepler's perspective. But not all such dimmings are caused by exoplanets, and scientists had to follow elaborate procedures to distinguish false positives from the real stuff, according to a NASA statement. ExoMiner is a so-called neural network, a type of artificial intelligence algorithm that can learn and improve its abilities when fed a sufficient amount of data, and Kepler generated plenty of data. In the less than 10 years of its service, the telescope discovered thousands of planet candidates, nearly 3,000 of which have since been confirmed. That is a vast majority of the overall 4,569 exoplanets currently known. For each candidate exoplanet, scientists pouring through the Kepler data would look at the light curve and calculate how large a portion of the star the planet seems to be covering. They would also analyze how long it appears to take the would-be planet to cross the star's disk. In some cases, they observed brightness changes are not likely to be explained by an orbiting exoplanet. The ExoMiner algorithm follows exactly the same process, but more efficiently, which allowed the researchers to add a batch of 301 previously unknown exoplanets into the Kepler planet catalog at once. When ExoMiner says something is a planet, you can be sure it's a planet. Hamed Valazedegan, ExoMiner project lead and machine learning manager with the University Space Research Association at the NASA Ames Research Center, said in the statement, ExoMiner is highly accurate and in some ways more reliable than both existing machine classifiers and the human experts it's meant to emulate because of the biases that come with human labeling. Now that ExoMiner proved its skills, scientists are looking to use it to help sift through data from other existing and upcoming exoplanet searching missions, such as NASA's current Transiting Exoplanet Survey Satellite, TESS, or the European Space Agency's Planetary Transits and Oscillations of Stars, PLATO, mission that will launch in 2026. Unfortunately, none of the newly confirmed exoplanets are likely candidates to host life, as they are outside of the habitable zone of their parent stars. Extreme exoplanets that are out of this world. Even though scientists were certain that other stars orbited other stars, there was little evidence of other planetary systems until the discovery of two extrasolar planets, or exoplanets, orbiting the pulsar PSR 1257+12 in 1992 by Alexander Wolskin and Dale Frail, as logged in the journal Nature. This initial discovery was soon followed by the observation of 51 Pegasi b, the first exoplanet discovered around a sun-like star in 1995, for which astronomers Michael Mayer and Didier Queloz were awarded the 2019 Nobel Prize in Physics. Since 1995, our exoplanet catalog has rapidly expanded. We have now confirmed over 4,000 worlds outside our solar system, with a further 7,000 or so suspects waiting to be classified, according to NASA. From worlds that rain iron and glass, to diamond worlds and planets that have escaped the grip of their parent stars, here's a look at some of the most fascinating exoplanets. WASP 76b, the exoplanet that rains molten iron. The night side of WASP 76b may be cooler, but it's no more welcoming. Spotted in 2013 and further investigated by the Espresso instrument on the Very Large Telescope in 2020, WASP 76b is a planet that is tidal locked to its parent star, BD plus 01-316. This means that one side of the planet permanently faces the star, causing scorchingly hot temperatures of around 4,532 degrees Fahrenheit, 2,500 degrees Celsius, hot enough to vaporize iron. The star-facing side of WASP 76b is roasted by radiation that is thousands of times more intense than that Earth receives from the Sun, while the side that faces away from the F-type star experiences perpetual night. Yet, even though the day side of the planet experiences hellish temperatures, that doesn't mean that conditions on the night side are a walk in the park. The side of WASP-76b that faces away from the planet's parent star is cooler by at least 1,832 degrees Fahrenheit, 1,000 degrees Celsius. But this means that when iron vapor is carried across the hemisphere by powerful winds, they are cooled, forming liquid droplets. These droplets of molten iron then fall, bombarding the cooler side of the planet. The key clue that allowed astronomers to discover the presence of these iron rains came when the espresso instrument was used to investigate WASP-76b's atmosphere, and no traces of the element were found on one side of the world. WASP-76b isn't the only planet that experiences nightmare rains of this nature. As is often the case with exoplanets, further discoveries don't just up the ante, they make things a whole lot stranger. HD 189733b, showers of molten glass. From space, HD 189733b may appear to be a beautiful and tranquil world, resembling a giant glassy blue marble. With exoplanets, though, appearances can be deceptive, and this definitely is the case for this gas giant planet that completes an orbit of its star in just 2.2 days. In fact, its beautiful blue hue arises from its deadly weather, particularly the molten glass rains that pelt the planet's surface. Yet, this isn't the extent of the planet's almost maniacal weather conditions. The exoplanet, discovered in 2005 by both NASA's Chandra X-ray Observatory and ESA's XMM Newton X-ray telescopes, also experiences winds of around 5,600 miles, 9,000 kilometers per hour. These supersonic winds cause the exoplanet's glass rains to arc sideways towards the ground rather than just falling, also picking up silicate particles, turning them into microscopic projectiles. HD 189733b isn't just interesting to astronomers because of its unusual and hazardous weather, though. The giant exoplanet has been observed to possess an atmosphere that is much larger than scientists would expect for such a world, according to NASA. This extended atmosphere works to catch more of the considerable radiation HD 189733b receives from its parent stars, thanks to its perilously close orbit, meaning the gas giant experiences temperatures as high as 1,700 degrees Fahrenheit, 930 degrees Celsius. Gliese 1132b, the planet that grew a second atmosphere. Gliese 1132b is similar to Earth in a striking number of ways. Its radius is only slightly larger, as is its mass. Even its age, 4.5 billion years old, is similar to that of our planet. But this world does have one striking difference. It orbits much closer to its red dwarf parent star, completing an orbit in just 1.6 Earth days. This proximity results in Gliese 1132b experiencing a much higher surface temperature than our planet at 278 degrees Fahrenheit, 137 degrees Celsius, with the intense radiation stripping the exoplanet's atmosphere. Yet, astronomers have recently discovered that something extraordinary is happening on Gliese 1132b. The gravitational influence of its star, 20% larger than the Sun, creates intense tidal forces that squeeze and stretch the planet. This flexing gives rise to violent volcanic activity and causes gases to rush to the world's surface. These gases are building the world a second atmosphere, according to NASA. Whilst this is exciting in itself, being the first time astronomers have spotted anything like this, the regrown atmosphere due to its origin also provides astrologists with a unique opportunity to study the interior chemical composition of an exoplanet by proxy. Kepler 10b. Kepler 10b orbits close to its host star, similar to the Sun, at a distance that is a 20th of the orbit of Mercury. This results in an orbit less than an Earth day and a surface temperature hotter than 2,372 degrees Fahrenheit, 1,300 degrees Celsius. Because Kepler 10b, discovered in 2011 by the Kepler telescope, is tidally locked to its star, it also creates molten droplets of iron and silicates. The planet's surface is likely covered with lava much hotter than that found on Earth. Because the harsh radiation from its host star has stripped away its atmosphere, these droplets on Kepler 10b won't fall on the night side of the planet, instead of being blown clear of its surface by stellar winds, giving it a fiery tail. Upsilon Andromeda b. Upsilon Andromeda b is another exoplanet that is probably tidally locked to its host star, completing an orbit in just under 5 days. What makes this planet, which was previously known as Safar, an extreme world is a radical difference in temperature between its day side and night side. Whilst the day side experiences temperatures as high as 2,912 degrees Fahrenheit, 1,600 degrees Celsius, the night side is considerably cooler, reaching temperatures as low as -4 degrees Fahrenheit, -20 degrees Celsius. This means that passing the hemisphere of this world could be considered equivalent to jumping into a volcano. While this is by no means the only tidally locked hot Jupiter, the others we have discovered don't seem to feature such radical disparities in temperature between their star-facing and star-ignoring sides. The reason this exoplanet experiences such a radical difference in temperature could be due to the tremendous size of its parent star, Upsilon Andromedae A, or the fact that the star possesses a hotspot almost directly overhead this exoplanet, according to NASA. HR 5183b, the Whiplash Planet. In terms of exoplanet discoveries, HR 5183b, a superjupiter, 3 times the mass of the solar system's largest planet, is unique as its orbit is highly eccentric both literally and figuratively. While most planets trace out a mostly circular orbit, this gas giant traces out an egg-shaped orbit around its parent star, HR 5183, according to astronomers at Caltech. Astronomers discover the exoplanet by the tiny wobble its gravity causes upon its parent star, which in turn causes a dip in brightness. The process took a staggering 20 years of observations with 3 telescopes, including Hawaii's W.M. Keck Observatory. Despite this long period of observation, we are yet to see the world complete a full orbit, with researchers estimating that this could take between 45 to 100 Earth years, probably 74 years. If HR 5183b was to follow its orbit in the solar system, it would pass closer to the Sun than Jupiter, and then move to the outer edges of our planetary system, swinging past Neptune. Highly eccentric orbits such as this have been observed before, but normally by planets and other objects that are much closer to their host stars. If HR 5183b's loose association with its parent star is something of a surprise, some worlds have gone to even further extremes, disassociating with their parent stars entirely to wander the universe alone. Now, if you think this insane discovery is interesting, you need to watch the next video about the new types of space rocks astronomers found.